Hello and welcome back. In this video we're going to explain the basics of the vertical motion model. Vertical motion model. A projectile is an object that is propelled into the air but has no power, this is key, no power to keep itself in the air. A ball thrown is a projectile because it has no power, but an airplane is not because the airplane can keep itself aloft. And the height of the projectile can be described by the vertical motion model. The height, we're talking about the height. Now here's the formula itself. H equals negative 16t squared plus Vt, V times t, plus S. Now H is always going to be the height in feet. T is always going to be times in second. V, which is this one right here, is the initial upwards velocity, and we'll explain that here in a moment. And S is the initial height in feet above the ground. Sometimes we leave that as 0. So for this example, we're going to leave it at 0. Later on, we'll go ahead and put something other than 0 in there when we're more familiar with how to factor. Now, some people ask, well, what is this negative 16 right here? Well, that's the gravity constant pulling down on the object. So it's being pulled down at 16 feet per second per second. So the S again is, let's say we have a bottle rocket sitting here. If the bottle rocket is on the ground, then that means S is equal to 0. So there would be no S in our problem. Let's suppose that the rocket was launched from a table and the height above the ground of that table was 3 feet. Then in that case, S would equal 3 feet. So the model does take into effect or account that the rocket or whatever item is being launched from the ground or not from the ground. But for now, we're just going to assume it's being launched from the ground. For this example, we've got a water rocket that is launched from the ground with an initial velocity of 150 feet per second. And what we want to know is after how many seconds does the rocket land on the ground. So we want to know is the total flight time. We are going to assume it's launching from the ground as it is, so our S value is going to equal 0. So from now in the next couple of days, our S value is going to be equal to 0. So there's really no S value in this problem. All we're really looking at is this negative 16t squared plus Vt. So our height is going to equal negative 16t squared plus, now our initial upwards velocity was 150. So basically V equals 150. So we'll put in our 150 and then our T. So the height above the ground, or height above the ground, would be equal to 0. So basically we're going to substitute H and force it equals 0 like we learned in a couple of other videos. One of the techniques for solving quadratics is to force it to equal 0. But in order to solve this for t, which is the time value, which is what we want to know, we have to do a little bit of factoring first. So we look at these two and we factor out the greatest common factor. Well, one of the things to make this easy, especially if you only have a t squared and a t, is to divide the t out. So bring a t outside. Now the 16 and the 150 have other factors in common that you could factor out, but we have a calculator that's going to help us solve that anyway. So I'm just going to leave those inside and just factor a t out. So when I factor a t out, the first one, I get a negative 16t plus, and when I factor a t out of this one, I have 150 left over, and the whole thing is equal to 0. Now remember, we solved this using the zero product rule. If two numbers, this number and this number, multiplied together give you 0, then that means one of them is equal to 0, so t equals 0, or negative 16t plus 150 equals 0. Now t equals 0 is obviously one of the answers because there's nothing else to do. So what we need to do on the second one is solve for t. And all you're going to need to do is pick up your calculator and subtract 150 from both sides, and we end up with negative 16t is equal to negative 150. Then divide both sides by a negative 16. It is going to give you approximately 9.375 seconds. So we have two values. It hits the ground at 0 seconds and it hits the ground at 9.375 seconds. So it's actually in the air for 9.375. And some people don't understand, well, why is it 0 also? Well, let's take a look at what this graph would look like if we were to put this in a calculator. So we've got the ground level right here, and the rocket is starting at 0 seconds right on the ground. And this is our time value here. So this is time in seconds. And as the rocket goes up, time is progressing outwards towards that 9.375 seconds. And this over here would be the height above the ground. So we can see the path that it takes would go up, it would reach a maximum point, and then would come back down. So basically we're asking, where does this graph cross the x-axis twice? In this case it crosses at 0 and it crosses at 9.375. But the question we're looking for, the answer we're looking for, is the one on this side, because we know it starts at 0 on the other side. We just want to know how long it takes to actually hit the ground. Or in other words, how long was it in the air?